Hello there and welcome back. In our last video, we were able to build the parser and generate an abstract syntax tree, AST, for our little expression evaluator. If you've not seen that video, check it out first. In today's video, we are gonna focus on making an interpreter, a small one, just to kind of go through our code and evaluate the abstract syntax tree. Remember, we are doing a stripped version where we're just doing the simple plus, minus, addition, divide operators. But once you're done with this first cycle, we'll be able to add more functionality into our scripting language. So to get us started, let's come to our include, and then I will add a new folder here. I'll just call it backend, and inside backend I will add a new file. I will call it runtime. I'll call runtime.h. So in our runtime, we'll be able to define the runtime structure that will be able to encapsulate all our data types, kind of. So let's define here a struct. Let's call it a runtime variable, and our runtime variable will consist of a couple of things. One of them is what you call runtime variable type. It's an enum, so I'll just do here enum class that one, and its options, one will be a string, number, nil. What am I forgetting? String, numbers, nil. I will have true, false, and this will just be called type. So we'll have an enum type of either string, number, nil, true, or false, and then we'll have std string of the value. So we'll have the string representation. So we also need to include here #include string, and so this will always represent a runtime value from in our particular instance. Now there are some utility methods I need to add here. I'll do to double, and this will return so if type is equal to runtime var type dot number, if this is true, we will return std of value, else we'll return okay, let's just do first let's get this condition out. Let's get this condition. Let's do if. So if that's the case, we return the conversion. else we throw good. So to double, similarly, I will do one for the string, and for all of them, I'll just return value. And then the other ones I will do two booleans. If value is equals to false, or value is equals to nil, return false. Otherwise, return true. For numbers, let's do if type number, you return to double, so it's, as long as it's not equal to 0, then we return true. But if it's equal to 0, we return false. Otherwise, okay. So to string, to double, to bool, that's enough for use case. So runtime varies. It's enough. Let's add a new file. I'll call it interpreter.h. We'll do yes class and interpreter. This will be default. Let's do, it returns a runtime variable, a method called eval. And eval will take a const std string reference of user input. So this user input is actually what we're already passing in our parser or in our Alexa. So in this sense now, in our private here, we need to create our parser. And then here we can do parser dot pass, and we'll pass our input string. So let's also include our parser. And our parser returns nothing. So in our parser, let's go back to our parser. We need to access this program node here. So down here, I will do program. I will return it as a reference, and I will just do root, and then I will return program. So that will give me access to this program, which is the root program we have. Let me save that. We'll come and move all these methods later to the .cpp file. In our interpreter.h here, I want also to include here is an ordered map. In our private here, I will do an ordered map of std string. It will take a string, and on the other side it will take a runtime value. And this will be this will actually be our storage for variables that we need to access and use it to maybe do something in our calculations. So here I will call it verse. Let me just call it actually for now. Should be std and ordered map. Okay. Let me actually just call it m underscore that way. And then in once we have evaluated, you have passed our input and there's no error, short we really have generated our AST. I will do our parser and I will get the root, and then I will do evaluate, and in evaluation I will pass in mvags that way. So you have not actually added this method yet, but we'll add it slowly. I will add it shortly. But eval will call recursively to each and every node to evaluate itself and return the resultant. And then I'll just return actually that here. And that might be all I need to do within the interpreter itself. So if we come back to main.cpp, we'll not really be worrying so much about this part. So I can safely delete. I can instantiate in my interpreter as IP. And then for this case now, I might move my interpreter out here, but for now that does not matter. And then I can do auto result is equals to IP dot eval, and then I'll just do std dot cout. I'll do res dot to string. So for the resultant, because it's returning an runtime value, I will just convert it to string and log it out. So let's include includes, we'll do expression, we'll do now backend, we'll do runtime, sometime we'll do includes, we'll do expression, we'll do backend, we'll do interpreter .h. So with those two in, Yeah. It's okay. Let's save this part. And then, so one thing is missing here. We need to pass in the input, user input. And then let's fix this private constructor being called, which I think I know. This should be set to public here. Good. And then if you come back to our main file, now everything, there's no longer any more errors, so that's good. Let's go back to our AST. In our AST, first and foremost, at the topmost here, let's include an ordered map, and then also here include backend runtime. So for each node, you also need to have a virtual method that returns runtime value, or variable value, or whichever. It's called a val, and it only takes std and ordered map. I think I can pass as a const reference. It takes std string and runtime var. Good. So similarly, so this will not be implemented here. Let me implement it where it will make more sense. So in our program, nope. I will implement it now from binary expression. So let me put it here. And then, being virtual, I need to do an override here. For now, let me just return empty braces, and then we'll sort that shortly. For numbers, similarly, for boolean types, for strings, for identifiers, for nulls, good. So if we come back to runtime and okay, it's fine. Let's go back to AST for now. So if it's a non-literal, what we need to return here is for the type, it will be nil. And for the value to be nil, that way. So for the primitive types, we'll just return as it is. So like for nulls, we'll just return a null or a nil value. For identifiers, it's a bit different. So for identifiers, we need to confirm if that contains so if it does not contain the particular key, but if it contains that key, we just return verse dot value. We already have return. Undefined variable. Good. So if I think ClangD might be giving an error here, but we'll confirm once we run the whole thing. So for identifiers, we need to check if the identifier name exists maybe in our variable storage, which we're using an ordered map here. If it exists, we return it. If it doesn't exist, we throw an error. That means the particular key, that's the identifier, has not been defined. Now, if you come back up to these are string literal, so I think for this, so here will not be nil per se, it will be string, and then for the value we'll have value. So the same I think will apply for booleans. And for this it will be boolean type. Oh, I think here is where we need to confirm b.value. So I think let's just keep it to bool instead of true and false. So I will collapse these two into bool. And then that still takes a value. Okay. So for booleans that works okay, and then we come to numbers. This is number, value is value, good. And then we'll come up to binary expressions, good. So let's implement the eval method for binary expressions. And for this particular one, we need to evaluate the left-hand expression first, also evaluate the right-hand expression, and then now do the operator part of it. So to do that, inside this, okay, so let's return, and for this case, let's return left, and for left, let's do eval, and for evaluation, let's pass in the vars, and then okay. So I think we need first to evaluate left and right. So let me just assign the result from the left of expression to L. You can better rename these things to something different later, and then R. We can do right dot eval, also passing the variables, and then now depending on the operator we have within this block. Let's start with if the operator is addition, in this case plus. If that's the case, let's return L plus R. I know this will throw an error, but we'll fix that in a short while. So let's do for the rest. So let's convert this to else if, and then similar to this, else if, and then finally we'll do an else block, and here we'll just throw std runtime. I can do std format and implemented op. And let me just pass in the op for now. We can better change some of these operations, logging and things like that, to make more sense later. So for minus, I think multiplication as well is the star operator, and for division, so let me add those here very quick: multiplication and subtraction. Now, to implement these operators for these particular different things, I'm gonna make use of operator overloading in C++. I know most people really don't like it, but hey, it actually gets the work done. So we'll switch now to our runtime.h, and then for the class runtime var, the struct, we'll do operator overloading for plus, minus, multiplication, divide. And there as well, we'll be able to handle to confirm if the operands to every operation actually makes sense. So in our struct called runtime var, after all these member functions here, let me add, for each of the operator we just discussed, the runtime var, we do operator, and then let's do plus, and this will take another runtime var. Let me even take it by reference, and this is, I'll just call it other. And so I think we can do a const ref, and from this we need to return, depending on if it's a string, we need to concatenate the string. If it's numbers, we need to sum and then return the result. If it's any other kind of type, then we throw an error because we don't support it. So let me copy that, and then I will do it for each of the other operators. And then this will be division, this will be multiplication, this will be subtraction. Good. Now inside here, for operations like plus, we need to ensure that both operands are the same type. So I'll begin by first doing if the type which we are currently in is equal to other.type. So I'll invert this, so if it's not the same, we'll throw std runtime expected same types to operator plus, but found, here we found let's do that and that, and then I can do type string, and the other one is other.type string. Good. I think type string can why are we getting that error? Let me move this to a new line just to see everything. So you want me to remove the const here? I see. So here we're supposed to do std format to wrap around that. I believe const here should not work. Okay, let's remove it for now. We'll come and check some of these things later to just ensure we don't introduce bugs. So if the types are not the same, we throw an error, and then that means the types are now the same. So we need to check also if type is equal to string. So if it's a string, we need to return a runtime type of string, and then the value here will be equal to let me just use the constructor, will be value and then other.value. As simple as that. So if it's strings, we just concatenate and return the result. And then if it's numbers, so the type is number. So we need to get the double value for the numbers and then add that and return a new. So I will do result here and I will do to double. This will call the double for this particular instance, and then we'll add it to other dot to double, and then the result will return number, and because our constructor requires a string, why don't I add a different constructor that takes in a number? Yeah. Runtime var. So I will add a new constructor inside this struct, and I just call it runtime var. So one will take a bool t, and if it's a boolean, then I think we have, oh, so if everything is public. Let me just add this for now here, and then double d double. I also do, we have booleans, we have, yeah, I think those two. I can move these ones to, okay, let's just leave them there for now. So for boolean types, we'll just instantiate with that what has been passed in, and then for the value, because it expects a string, so we'll just do, if it's t, we'll return true, else return false, and that's it. So we also need to mark this as explicit. That way you don't have events are const as well. Oh, type. The other thing we need to also instantiate here is the type. And for this, it will be a boolean type. So we can reformat this then into new lines. This one again. Okay, all of them actually. Good. So we can, by the magic of copy and paste, we can do that. And for this, we'll do here double D. This will be a number. This will be a D. Okay, let me just use std format. And here it will take the double D. Okay. Oh, this should be D value. Good. Okay, that's good. So we've done for those two. I think we can instantiate this to false. Okay, anyway, this one to 0.0, and the string has a default value. So if you come back here, for string, you can do runtime var. So we don't have a default constructor for this case. So here will be std string v, and this will be a string. So we'll set this to v, and then good. So if you're given a string, we'll call this first constructor, or else we'll call the others. So you may need to refactor the other methods you had already done to reflect these changes. So if you come down here to our method, we need just to do, for string, we need just to concatenate them. I think no need even to call that. Okay. Okay. So that should call the string constructor and create a new string result. For the number, we need to only return the result here. And for this, I will do runtime var, and that should give us the result. Oh, we need to have a semicolon here. So if it's not a string and it's not a number, that means either it's a nil or it's any other thing. So I think we need to throw an error. So I will do here throw std. We don't really expect it, but yeah. Runtime error. You'll do here std format, and inside here I will do op plus not supported for type, and then I'll just do here type string. Good, that way. So if maybe you pass in a boolean plus a boolean, we throw this error because it will pass this check. So we don't support boolean plus booleans, nil plus nil, so things like that. But if you're adding a null to a null, okay, let's leave it at that. So with the same logic, we'll copy it, and then also for subtraction, we'll be able to do the same thing. But for this case now, we don't support subtraction for strings. So we only support it for numbers. I think we have an issue with const here. So only numbers can do this kind of subtraction. So we'll throw that error there. For multiplication and division, let me first start with division here. We don't also support strings with that. We'll do division directly. We'll remove this const from here. And then for multiplication, I have so first of all, for numbers, that's fine. We need to do multiplication here. So let me first remove that. And then for strings, I have an idea of multiplying a string to a number, like how Python supports it. But for now, let's also just remove it. That can be additional things to do later. And that's it. We have done all the 4 operators, plus, minus, division, and multiplication for this particular type. We'll also come and add later the modulus operator for getting the remainder for this kind of operations. In as much as people don't like operator overloading, it might be useful for such use cases. So let me save this, and let's go back to our interpreter. And for an interpreter, I think we're calling that. Good. Let's go to AST. So now all the errors on this binary evaluator are gone. So we are doing the right operations here, and then if we don't get it, we throw that. Good. Now let's go back up. I believe that's all we need to do. Let's go back to main. In main, we are doing that, and that will give us, so this will return a runtime value. Oh, okay, yeah, that's fine. So the toString will just return the value we have. So let's try and run the whole thing. We might get some errors, but let's just figure out what are those errors first, because you've kind of changed some methods. Let's start from the top. Okay, so in runtime.h, we need to include format.h, the format class, and then so runtime. So I think that should solve most of the errors. So let's rerun this. Good. So let's look at the other part. Yeah. In AST. So in AST we were creating the runtime var. So eval, so we're just supposed to return a double here, and this will be runtime var, and that will handle it. And then for booleans, same thing here, we need just to return the b value. Similar here, runtime var. For strings, we also need just to return the value. And then for identifiers, it's similar to strings. Yeah, I think that's good. For null, I think we can do an empty runtime var. But for this support, we need to implement it. So if we come back to runtime.h, so we can add another runtime var which takes no arguments, and then for the type it will be null, and then for the value it will be nil, and that's it. Oh, it should be nil, not null. Yeah, good. So let me just format that to bring that to new line. Good. So let's rebuild this again. So we are passing this as a const, and it's actually complaining about that. So let's come back to identifiers. We'll have to do that. Let's drop the const in all our eval methods for now. Let's just pass them by reference as it is, and then so similar here. Good. So let's rerun this. Let's come back to node, and I see. This is declared virtual, but it's never implemented. So we'll just return that way. So we'll just return null for this particular use. Let's see if that fixes the issue per se. Nice, and that fixes the issue. So let's do 1 plus 1 should be 2. That comes back as nil. 1 minus 1, nil. 2 times 3, nil. So far, when we run our program, we are getting nil everywhere, and instead of actually getting the evaluated string. And this comes from the program node. The program node has no eval method, so it's calling the method which is being evaluated here is from the root node, this one. And since this returns nil, so everything just comes back as nil. So what we need to do is that we need to implement the eval method for this one as well. And that should not be virtual per se, it should be override. So we are overriding the eval method, which is defined in the root node. And for this one, what I'm going to do is that I will create a result runtime var. So that will be null. And then that's what I'll still return at the end of this block. And since we have a vector of unique pointer nodes, so we need to recursively, we need first to loop over every node in the vector and evaluate. And for each node, we need to recursively call each other until it's evaluated. Inside here, let's create a for loop. And I will just do const auto. I just call it a node in AST. And then for each node, I will assign res to the node. And for each node, let's evaluate. And let's pass in the vars that way. So this will go over each and every node, and for the result, it will just put it within the res. And this is what will return at the end of this block. So if you have multiple nodes within the same statement, or within the same node here, we'll evaluate them and just return one result at the end. So let me save that. Let me exit this and let's rebuild and see if that fixes the issue. So let's do 1, we're getting 1. Let's do 2, 3. Let's do a string of hello, and that's fine. So we can also do nil, that's still a nil, that's fine. The other things we support is true and false. So all of them are coming out correctly. So let's try and do some simple mathematical expressions. Let's just take 1 plus 1, which is supposed to be 2. So we're getting the right answer there. So 2 minus 4 is -2, which is fine. The other one is 3.45 divided by 1.2, and that throws an error. Oh, yes. So this is failing because so far within our lexer, we are only passing, we're only lexing integers, not floating points. So the dot here is not, it's not none, so that's why it's actually throwing an error, which is fine. But basically our script is working correctly. We can even do 2 into 3 minus 4. So 3 minus 4 is -1. -1 times 2 is -2. It's interesting. I need to figure out why that happens, but let me just do 3 minus 3 that way. Okay, that's fine. Let's do 3 minus 3 over 2. So 3 over 2 is actually 1.5. Yeah, so 3 minus 1.5 is 1.5. That's correct. So 3 divided by, let's do 1 over 3. So the answer should actually be 1. Not actually 1, it's 9. So this will be equal to 3 divided by a third, which is 3 times 3, which is 9. Okay, that's correct. We can also do 45 plus 2. 45 minus 2 plus 5 times 3. So let me copy the same expression here, and I will open calculator. It's saying 58, but yeah, okay, yeah, that's correct. That's correct. Good. So basically our whole thing is so far well done. So what the next steps, of course, is to figure out some of the other minor bugs we need to fix. But for the next video, what we are thinking to do first of all is to add some other operators like the logicals like less, greater, equal to, not equal to, and those will now add some more functionality into our language. Additionally, once you're done with that, we can look at now cleaning up the whole thing, maybe restructuring the whole program, and then of course we'll be able to fix some of these issues like what you're seeing here. So whenever a bracket comes in like this, if it's not preceded here by an operator, we need to actually add a multiplication. So that will fix the issue whereby when you do 1 into -1, so this should be -1. It's actually saying a non-token, which is negative here. So we are not supporting unary. Unary is here, so that's why this is actually being thrown. But also we need to support unary operators whereby you can invert, you can negate, and that should enable us to do some of these operations like this. So yeah, but basically this so far a working interpreter. So one last part to add before we close it is that whenever we throw an exception, so far it's actually shutting down the whole program. So that's not what we intend to do. So I'm going to wrap the evaluation as well as the whole program here with a try catch block. And then if by any chance we actually fail, I will use that to do a.what. And in the near future, we can even add the line number, the character number, and other things to help us debug exactly where the error was thrown or where the error comes from. And yeah, so for our interpreter, let me remove that from that point. I will put it to be outside the while loop. So we'll instantiate, we'll create the instance from we'll create an interpreter instance outside the loop, and then within the loop we'll continue just to check for user input, check if it's an exit, lex, pass, and evaluate the user commands, and then if it's an error, we show the error, and then we loop again over and over. So the reason we're moving this one outside is that at some point we need to support setting variables, and these variables might be things to do with like numbers, strings, and things to do like that. So for now, to support that part of the program, I'll come inside here, and I want to add a means to add and remove variables from the interpreter stack. So using an ordered map here to store the identifier name and then the value assigned to it. So for a case, I will come here and I will do void add variable, and then this will take first of all a constant set of string called identifier, and then a runtime var, which is the value. And I don't care much if it exists or not already. So if it exists, I will overwrite. If it does not exist, I will create it. So I'll just do your mvars and then give it the ident and then assign the value here. So if this key does not exist within the map itself, it should be added in. If it exists, it will be overwritten. So that's why I'm doing that. Similarly, you can do runtime var get var, and this will just take the key. So we'll just do a const after the string by reference, and I will just do indent. And so what you need to check is if a map contains the key first and contains. So contains is a C++ 20 method. I think that's why Clang is really complaining a lot. So if it contains if it does not contain it, so we are negating. If it does not contain it, so we'll actually throw std except runtime exception, runtime error, and here we'll say undeclared variable, and then ding ding. I'll do ident, and then of course I need to use std format, and if it exists, we'll just return mvars, and I will do ident. So is it std formatting included? No. So include format here. So now that means that if we can add new variables within our stack, and also we can also fetch if they actually do exist. So let me do that. So because this functionality is here, at some point we'll move most of the evaluation work into the interpreter itself, instead of having it within the AST. And we can both use these methods more efficiently. So anyway, so with this saved, I can come back to main here, and I can do IP, and I can add var. And so let me just call it, let's say name, and then for the runtime value here, I will pass the name John. So so let's add a variable called name. Let's copy and paste that a couple of times. So I will do a first name, last name, and then I'll do here John Doe. I will do maybe X, and maybe I'll assign it to 23.45. Let me add one more. Let me actually do 3.14. So let's call it this pi in capital. So let's make use of these variables, since they're already declared within the program itself. Let's do here exit. Let's compile again. Oh yeah, we have a typo. Ident. Okay, good, that's fixed. So let's rebuild again. Good, so let's even do pi. So we're getting 3.14. what are the other ones? So we can do first name. Interesting. So we are having a very weird issue here. It looks like we are storing the data, yes, but it's actually getting overwritten. Why is that the case? Let's come back to our AST. So when you are evaluating, okay, I want to go down here, and in here when you have a null, so I will do a stdc out, and for each I will just call dump the serialize, and I will do here true, and I will do end line. So for each eval node, as long as it's a primitive type, I would like to dump it. Oh, this for the numbers, yeah. Good, that's enough. So let's exit this, let's rebuild, let's run it again. So number literal, and then this is I think I'm seeing where the problem is. I'm seeing where the problem is. So for each evaluation cycle, okay. I see. So our quick hack here will be to reset the lexer and the parser on every call. We should have done that. So so parser will call pass, and in pass we need to reset. We come to parser. So we have in parser we have the lexer. So in lexer we have the tokenize, and then we are creating tokens. So we have this vector of tokens. So when you call tokenize, so in the lexer.cpp, when you call tokenize, we need also to reset. We need to reset. So inside here, we need to do tokens.clear. Also, when you're building in the parser where you're building, I think in the program, so within the parser itself, so parser.cpp, so this program node, I need to do also program.clear, and that should reset everything within the program node. So it's kind of returning some old data when you run it. So under the program node, let's add here, we'll do here void clear, and this will do ast.clear. Let's see if that fixes the issue. So let's do 1, let's do 2, good, 3, 4, 5, 6, good. So now if we do pi, it's 3.14. If you do f_name, it's returning true, and I think I know why. So there was an error here within the main.cpp. I think it's actually being converted to std bool. So let me do here std string. So let's rebuild, let's clear and rebuild again. So if you do pi, we do _name, good. So now we can go to do pi times 4, and that's pi, which is 3.14 times 4, which is around 12 point something, so that's fine. We can do f_name plus l_name, and we have a John Doe. We can have a space in between and do space, or even you can do comma space, and also add l_name. Let's even add another one, and you just do exclamation here. So you get John, Doe, exclamation. So everything works okay. So this is basically how we can have variables defined and declared. So of interest first is for us to implement the other operators like greater, less, equal to, not equal to. We should also add unary operators, that is to negate and to not. That shall do once in the next video. And then in a future video, we'll now look at how to add functionality for declaring your own variables. So if you have a variable, let's say called x, you want to assign x maybe a value of 10, we'll add that functionality in. All along we'll be doing more cleanup, so in next video I'll come back already cleaned up the whole thing, and the code for all this software will be linked down in the description. So have a test, run it out and see what you see. You find out once you run it, and I will see you in the next video. Bye bye, hope you enjoy.